Quantum computing represents one of the most revolutionary advancements of the 21st century. While traditional computers process information using bits, values of 0s and 1s, quantum computers harness the bizarre and powerful principles of quantum mechanics. They use qubits, which can exist in multiple states at once due to superposition and entanglement. This quantum nature allows them to perform certain calculations exponentially faster than even the most powerful classical supercomputers. But what does this really mean for the world? The implications are vast and potentially transformative across every domain of human life. The power of quantum computing lies in its ability to process and analyze data in ways previously unimaginable. Imagine trying to simulate the molecular behavior of a drug compound to understand how it might react in the human body. Classical computers can only handle simplified versions of these problems, but quantum computers could model them with atomic-level accuracy. This means quantum computing could accelerate the development of life-saving drugs, vaccines, and personalized medicine. In healthcare, quantum computing will be a game-changer. Drug discovery that currently takes years could be reduced to weeks. Genetic analysis and DNA sequencing, which are computationally intense, will become faster and more precise. Quantum machine learning could help identify diseases like cancer, Alzheimer's, and Parkinson's in their earliest stages, long before symptoms appear. By mapping out protein folding mechanisms, quantum simulations may unlock cures to currently incurable diseases. Financial systems are another area where quantum computing will leave a major mark. Today's financial models rely heavily on statistical approximations and heuristics. Quantum computers will be able to simulate markets in real time, considering countless variables and potential outcomes. This could lead to more accurate pricing of complex derivatives, better risk management strategies, and optimized portfolios that adapt instantly to changes. However, there's a dual edge. Quantum computers will also be able to break much of the cryptography that currently protects global banking systems, online commerce, and national security. Encryption methods like RSA, which are considered secure with classical computation, could be rendered obsolete. This quantum threat has already initiated a global race to develop quantum-safe encryption protocols, technologies designed to withstand the power of quantum attacks. Cybersecurity will need a complete reinvention. Governments and corporations are already investing in post-quantum cryptography. New algorithms, resistant to quantum decryption techniques, will need to replace existing ones across everything from email to blockchains. The transition will be massive, requiring years of preparation, but it's not a choice, it's a necessity. In the realm of artificial intelligence and machine learning, quantum computing offers profound acceleration. Quantum algorithms could drastically reduce the time needed to train complex AI models. Quantum neural networks may eventually surpass the pattern recognition and decision-making capacities of current deep learning systems. With quantum-enhanced AI, machines could analyze massive, unstructured datasets, video, voice, sensor data in real time and make nuanced, contextual decisions. This leap will also impact robotics, self-driving vehicles, and smart infrastructure. Optimization problems that previously required hours of processing could be resolved instantaneously. Logistics networks, like those used by shipping companies or ride-sharing services, could be optimized in real time with quantum algorithms, cutting costs and emissions. Scientific research will be transformed by quantum computing. Fields like chemistry, physics, and material science will see major advances. Quantum computers will allow researchers to model chemical reactions in full detail, enabling the design of new materials, superconductors, and catalysts. This could revolutionize energy production, leading to more efficient solar cells, powerful batteries, and even potential breakthroughs in nuclear fusion. Climate modeling is another area set for radical change. The climate is a chaotic system with thousands of interacting variables. Simulating its future accurately has always been a challenge. Quantum computing will allow for far more detailed models, considering a greater range of possible interactions. These insights will improve predictions, guide climate policy, and help develop better strategies for mitigating environmental risks. Quantum computing also holds the key to transforming communication. Quantum networks will use principles like entanglement and quantum teleportation to enable ultra-secure communication. Messages sent via quantum channels would be impossible to intercept or tamper with, providing absolute privacy. Countries are already experimenting with quantum communication satellites and fiber networks to build the future quantum internet. This new internet will be unhackable. It will support quantum cloud computing, where users can access quantum processing power remotely. Sensitive sectors, finance, government, military, will rely on quantum communications to protect critical information, and consumers will benefit from enhanced privacy and data protection as quantum encryption becomes the norm. Manufacturing will also evolve. Quantum simulation will help create novel materials, custom properties for use in aerospace, electronics, and biotech. From lighter aircraft components to superconducting circuits, the impact will be widespread. Factories will use quantum algorithms to optimize production lines, reduce waste, and improve quality control. Quantum sensors, a branch of quantum technology related to computing, will revolutionize navigation, medical imaging, and exploration. These sensors will detect changes in magnetic fields, gravity, and time with extreme precision. This will allow submarines to navigate without GPS, doctors to perform earlier and more accurate diagnoses, and geologists to find hidden resources underground. Space exploration is another domain that will benefit. Quantum computing will enable better simulation of orbital mechanics, spacecraft performance, and extraterrestrial environments. NASA and other space agencies are already investing in quantum research to prepare for the complexity of deep space missions. With quantum-enhanced AI, autonomous space probes could make intelligent decisions millions of miles from Earth. Despite its promise, quantum computing faces major challenges. Qubits are extremely fragile. They require ultra-cold environments and are easily disrupted by noise and interference. Building scalable, fault-tolerant quantum computers is still one of the hardest problems in technology today. Current quantum machines have limited qubits and high error rates, making them suitable only for certain experimental tasks. But progress is rapid. Major tech companies, Google, IBM, Microsoft, Intel, Amazon, and startups like Rigetti, IonQ, and D-Wave are investing billions into quantum R&D. Each year sees improvements in qubit quality, coherence time, and error correction. Quantum supremacy, the point where a quantum computer outperforms the best classical computer on a specific task, has already been demonstrated, but practical everyday applications will require further innovation. One important step toward widespread quantum computing is the development of hybrid systems, where quantum and classical computers work together. These systems will handle specific subtasks that are better suited to quantum hardware, while the classical processor manages general operations. This cooperative model will be the norm during the early stages of the quantum era. Education will play a critical role in this transition. A new generation of engineers, scientists, and developers will need to be trained in quantum theory, algorithms, and hardware. Universities and online platforms are already offering quantum programming courses accessible to both beginners and professionals. Quantum literacy will be essential, not just for specialists, but for decision makers in business and government. There's also the question of ethics. With power comes responsibility. Quantum computing could exacerbate existing inequalities if access is limited to a few powerful corporations or nations. Ensuring equitable access and global collaboration will be key to avoiding a quantum divide. Policies must be put in place to prevent monopolization and ensure that quantum benefits are shared across society. Intellectual property laws will need to adapt, especially as quantum systems begin generating new designs and inventions. The line between human and machine creation will blur. Legal frameworks must be agile enough to handle the complexities of quantum-generated knowledge. Looking ahead, the timeline for quantum computing's mainstream adoption is uncertain. Optimists predict widespread use within a decade. Realists suggest 2 or 3. Eventually, we'll reach an era where quantum computing becomes as ubiquitous as classical computing is today. It will be embedded in phones, medical devices, infrastructure, and personal assistance. The race for quantum dominance is not just a technological contest, it's a global turning point. The country or organization that leads in quantum computing could shape the geopolitical and economic landscape for generations. From drug discovery and disease prevention to securing communications and enabling scientific discovery, the possibilities of quantum computing are limitless. It will change the way we think, solve problems, and interact with the world. It may even alter our understanding of reality itself. In the grand narrative of human progress, quantum computing represents a bold new chapter. As we stand on the brink of this quantum age, one thing is clear. The future will be shaped by those who understand their implications and use them wisely. This is Future Life. Join us on this extraordinary journey as we continue to explore how cutting-edge technologies will redefine our world. The quantum era is coming. Are you ready?